by two cables, and the objective, of course, is to find out the tension in those cables. So, first of all, 1,000 kilogram. Is that a, what is it? Is that a weight? Yes? Yes? Have you ever heard of the terminology mass versus weight? What is the difference? Can somebody tell me what is the difference here?
Weight is corrected with a proportionality constant for being on Earth, and it's also a vector, so it has direction. Mass is universal. So on Earth, 1 pound force is equal to 1 pound mass. However, if you went to the moon that has 1/6 the gravity of Earth, 1 pound mass is still 1 pound mass, but it weighs 1/6 of what it weighs.
Right. So if I tell you, I mean, of course, it made sense to all of you, right? Have you heard of the terminology weightless? Where do you feel weightless? In space, right? So what does that mean? That means that you lost your weight? What does that mean? Come on, yes. Right, so the gravity is actually the part that is giving you a weight. So on Earth, you have a gravitational acceleration, which is that G over there. Therefore, you can walk. If I don't have that gravitational acceleration, what happens to me when I walk? Huh? Have you seen these movies on the moon? Person walking on the moon, kind of going like this, right? So what we have here, in fact, is a mass of 1,000 kilograms. If I want to convert that mass into an actual weight, what do I have to do? Have you? Yes. Right, of course. So the weight of this thing is in fact equal to m times g, the mass times acceleration. Why? Because the weight is actually a force. Why is a force? What defines a force? What defines a force? A magnitude and a direction. Like a vector. A vector has a magnitude and a direction. In this case, a person has a weight because of the gravitational acceleration that is pointing downwards towards the center of the Earth. That's where the gravitational acceleration is towards. Therefore, your weight has a magnitude and the direction. The direction is vertically going downwards, and the magnitude is equal to mass times acceleration. Therefore, if you're on the surface of the Earth, the G is 9.81, but if you go on the surface of the moon, that might be 0.04, which basically gives you that weightless phenomenon. Okay? Now, we're not really there to really discuss about, the weight and so forth. But the idea is that if I want to understand the tension in each cable, what is tension? What is tension? Right. So in other words, how much the cable is being pulled, right? Because that weight is kind of pulling it down. Isn't that true? It's pulling it down. The fact that it's suspended means that those cables are strong enough to withstand the force that is in that cable. If they were not strong enough, then what would have happened? Snapped, exactly. So the tensions in those cables, are they vectors? Are they vectors? Come on, take a crack at it. Yes. Why? That's right, because it has a magnitude and it has a direction. What is the direction? Upwards? Downwards? Yes. Up and down? If you look at the cable is being pulled, don't you think? So the direction of that force is in the direction of the cable, which of course means it has a vertical and horizontal components. Therefore, it is a vector. It is a vector that has a magnitude, which we don't know what that magnitude is, and the direction is alongside the cable. Right? It has a vertical and horizontal component. So, brings us to free body diagrams. How many of you have seen that terminology? Right. Those of you who've done physics, right? Free body diagram. Can somebody tell me what is a free body diagram? Yeah. Right. So basically a way to simplify the physical system. So instead of looking at this, I want to look at a simpler version of this problem that shows me all the forces. Free body diagram is a simpler form of a physical system like this. Right? So if I'm looking at this physical system, what am I seeing? I'm seeing a, well, let's see. I'm seeing a weight, right? A weight. And I'm seeing a force which is going downwards, which is equal to the weight and the tension in the cable. So the free body diagram is what I see over here. The weight going downwards and to tension. So this represents the whole system. Okay? So looking at this system, which is showing me the tensions in the cable and the weight, one thing else comes to mind. And that is really the principle behind static situation. Do you think if this weight is suspended, is that weight moving? No, it's not moving. Therefore, if it is not moving, it is in a state of what? Yes, equilibrium, right. State of equilibrium. And state of equilibrium does not have to only relate to static problems. You know, those of you who are going to be doing mechanical or electrical or even bio, you're going to get a static course. Equilibrium means when your system is not changing. When your system is not changing, it is in a state of equilibrium. For this to be in a state of equilibrium, what do you need to have? Yes. That's right. So the forces should counteract, with one another. In this case, the weight is pulling the system down, and the tensions of the cable are moving them up. Therefore, that's why the weight is staying stationary. If weight was more than T1 and T2, what would have happened? Would have dropped. Exactly. It wouldn't be there anymore. It would drop to the point that the cable keeps, the tension in the cable keeps going up. It gets to a point that if the weight is too much and the cable can't stand it anymore, what does that mean? That means the forces in your cable far exceeds the strength of your cable. That's why the cable snaps. So for us to have this state of equilibrium, what we need to have is that the summation of all the force vectors in this system should be equal to 0. Now you've already seen two cables are moving up, one is coming down, therefore that would represent the equilibrium for us. So in a vector form, we have two vectors in the opposite direction, T1 and T2, and W. Why don't I put negative there? Why don't I do that? Yes. You can't have a negative weight, yeah? Is that the answer? Because the negative or the positive will come up when you start looking at the directions of these vectors. At this moment, all I'm saying is that the summation of all the forces are going to be 0. But when I start replacing for the values, then it becomes a negative or positive. In other words, what is the direction? Our direction on the positive direction of x-axis is positive, negative direction is negative, y going up is positive, w going down is negative. So we could in fact have a negative weight simply because the directions that we have selected, upwards is positive, downward is negative. That doesn't mean that you have a negative weight. That means you're in fact actually giving weight to somebody. No, it's just that from the vector point of view is going downwards. So to put it in this format, we are saying that the summation of all the vectors have to be 0. So what we need to do is we need to replace for the values of each of these vectors. In this case, T1 is equal to minus T1 cos 45 degree I plus T1 sine 45 degree J bar. Where did I get that from? Yes?
The negative comes from like the general direction of the T1.
Right. So if, what is happening here? So in this case, if you look at T1, and this is positive J, this is positive I, T1 has two components. One is this component, the other one is this component. The component on the y direction, which is this, is it in the positive or negative direction? Positive. The component in the I direction is a positive or negative? Negative. That's why where this negative comes in, and the 45 degree is that angle. So T1 cos of 45 degree is there. And T1 sine is this one here. You understand? So that would be for your vector T1. So for T2, on the other side, what do you think you should have? T2 is this. So this is the I, and this is the J. Positive, positive. Why? Right. So that's why you have this. What is I and J? Yeah, but what do we? How do we define I? I was a unit vector in the x direction, right? J was a unit vector in the I direction. In this case, what is the difference between the T1 bar and the T1 or T2 bar and T2 on each side? What is the difference between the two? The one on the left is what? This one. What is it? That's the vector. The one on the right, scalar, of magnitude. We only make that a vector by using the unit vectors, I and j. So what you're doing is you are basically representing it in the x and y direction. So now I have T1 and T2. Now, if I want to write down the formula for W as a vector, what would that be? Because it has to be in the I and j, right? W as a vector. Yeah. Right. So it's 0 times I. In other words, there is no value in the I direction. So it's 0I plus 9.81 times 1,000, which is basically 981, times j. Okay? Because it has no value in the x direction. Follow so far? So now I have defined all the vectors. And we said that the state of equilibrium is when all of these forces added together should be equal to 0. So when one of you said, well, it is in the negative direction, I said, don't worry about it, because when we define it in the x and y direction or in the I and j direction, the signs will come. So we don't have to worry up there saying that T1 plus T2 minus W is equal to 0. Because W later on, it is going to be in the negative value. Okay, so all I have to do now is put these values in my equation. Where did I get T1 over square root of 2 from? Yes. Cosine of 45 degrees. What is a cosine of 45 degrees? Is 1 over square root 2 or root 2 over 2. Do you remember how we found it? Do you remember that table? 0, 1, 2, 3, 4. And we came this way. 0, 30 degrees, 45, 60, and 90. Remember all that? So this is how we do it here. So we can just simply simplify this. I've put the values of the vector T1, vector T2, and W, and it has to be equal to 0. So what do we want to find here? We want to find T1 and T2, the amount of tension in that cable. So how do I find it from here? How do I find it? Any idea? This formula has terms in I and terms in j. When you have equilibrium, basically means that this whole thing has to be 0. That means if I factorize I in this, then whatever is inside that bracket has to be equal to 0. Because in fact, this 0 is telling us is 0I plus 0j, right? 0I plus 0j. That means all terms of the I has to be equal to 0 and all terms of the j. So in that case, if I put that as equal to 0, meaning this part has to be equal to 0. And this part has to be equal to 0. We follow this? No? All right. So this part you follow, right? 0I plus 0j. Unit vector I, unit vector j. For this equilibrium to exist, and when I factorize I and j, look at it. Compare this part of the equation to this part of the equation. That means whatever is inside this bracket right here, whatever is inside this bracket here, has to be 0, because you're already saying it is 0. Right? So if I put this equal to 0, t1 square root of 2 plus t2 square root of 2 is equal to 0. What do I get? What do I get? t1 square root of 2 plus t2 square root of 2 is equal to 0. Yes? That's right. Right? So from the first part, I find T1 and T2 are the same. Now, does that mean, physically, does that make sense to us? Yeah. Yes.
Can you go back to the screen and ask the question? How come if the first one's negative, I don't understand.
This one?
Up to the top, next to here.
This one?
No, up away from the top. Or the circle.
Up there.
Yeah, why is that negative?
Okay. Can somebody tell me why is that negative? Yeah.
Because the x value for the first one is negative.
Right, because look at it. T1 is pointing in this direction. Pointing in that direction, consider that the point that is connected to that weight as the origin of your x and y axis. Anything on the right is positive, anything on the left is negative. T1 is pointing this direction, therefore the reflection on the x-axis is in the negative direction. Okay? Any other question? Yes. How did we get this? Okay, so when we are looking at an equilibrium, basically we are saying that the left side is equal to the right side. Right? If the left side means this is 0 and that is 0 too, which means that the factorized part of I must be equal to 0. That's what we're saying over here. Right? We are equating the terms. So when we are equating the terms, that's right. Okay? So that was T1 plus T2. T1 is equal to T2. So now we know that the tension in both cables are the same. So what is the next thing we need to do? Yes. Exactly. So we replace for T1 and T2 in the other equation, like this, so that we could find either one of them. Whether T1 or T2 doesn't matter. So all we do is replace it, and what we get is this. Now, would I be able to, did I have to put it in T1? Could it be T2? Yeah, they're both the same. So from here, T1 over square root of 2 plus T1 plus over square root of, which basically means 2T1 over square root of 2 is equal to 9,810. Would I be able to calculate T1 from here? We have one equation, one unknown. Now that I found T1, what is T2? Same, right. So now I found the tension in the cable. Does that physically make sense? The tension in both cables are the same, right? So one thing you have to learn in engineering is when you get the answer, make sure that it actually physically makes sense. If it doesn't make sense, if I came back and found out that the tensions in each of the cables was 12,000 newtons, would that make sense? It can be more than the weight that they're carrying, right? So you have to use your own sense or logic to figure out if the answers you're getting is the accurate answers. Any questions? Yes?
T1 and T2 should be vectors, right?
This, no. They are not vectors. Why are they not vectors? This T1 and T2.
Oh, because we factored out the J.
Right, because if you want to make it vector, then we have to define it in the vector form. And in the vector form, we defined it before. Do you remember? T1 times cos of 45 degree plus T2 times sine of 45 degree. That's where the vectors are. All right, so now let's do another problem. A simpler problem. Let's say that you have a 100 kilogram TV and is loaded into a truck using a ramp. First of all, 100 kilogram. Is that a mass or a weight? Weight? Mass. In order to get the weight in newtons, we have to multiply it by, right. So when I'm looking at this situation, what I am seeing is a TV and it's resting on an inclined surface. Now again, the idea here is really not to teach you statics. The idea is to teach, show you the mathematics and show you that there is a relationship between that mathematics and the engineering problem. So when I'm looking at that weight, which is on that slope, and it is not moving, okay? Right now it's not moving. It's in a static equilibrium. What do you think what are the forces in here? What kind of forces we have? Yes? What is friction?
Friction is the force between the cone and the piggyback.
Okay.
Which is the pushing out between the pushing the truck between the left and right.
So if you have a car traveling on asphalt, would that car travel faster on asphalt or on ice? Ice? Asphalt. Because on ice, there's not much friction. So although your tire is rotating, it can't move because there's not much friction between the tire. So friction is a force that basically is resisting the movement, right? When you have a friction between yourself and somebody else, what does that mean? You're not in agreement, right? You're in disagreement. So in this case, the TV is sitting on that inclined surface and it's not moving because something is holding it from moving, right? Something is holding it from moving. And then as you put more forces on that, you will get to a point that you actually compensate for the frictional force, and that's when it starts moving. So in this case, when I am looking at that TV, the first thing I have to do is to do what? To draw the free body diagram, right? The free body diagram. Right? Do I draw the free body diagram of the truck? No. What do I draw? Of the TV, right. So, let's look at the free body diagram. We have the TV. Now, the weight is always downwards towards the center of gravity, the center of the Earth. So this is your weight going down. But then we said that this is really sitting on a surface. On a surface that makes an angle 30 degrees. So now I want to show it, I want to use my vector analogy and show the forces. What kind of forces do I have? I have a friction force. Yes. I have the gravitational force, which is this weight, right? But the friction force is going that way. Why is it going that way? Yeah. Well, what is the tendency of the TV to move up or to move down? Therefore, always friction opposes the movement. Because if the friction wasn't there, the TV would have slid down. Right? So, what's that?
I thought we're moving, I didn't see left sitting on that.
No, the TV is sitting on the ramp, right there. So, this is your frictional force. What else do we have? Yes. Normal force. What is a normal force?
The force that is coming out of the thing it's sitting on,
Right?
that it doesn't fall through the earth.
There you are. For every action, there is an equal and opposite reaction. Have you heard of that terminology? Where did that come from? Newton, right? So when that weight is sitting on that surface, when it is sitting on that surface, if this normal force isn't there, what would happen? That's right, it would go through that surface, right? So the surface is actually opposing whatever force is being put on there. We call it normal. Normal means what? Normal? Normal in engineering means perpendicular. Whenever you hear the term normal, means perpendicular. So now we have all the forces that we want. We want the friction force because it opposes the movement. We have the normal force which opposes the weight or the force that this is, and of course the gravitational force which is related to the weight of the TV. So do we have everything we need in that free body diagram? All right, so the next thing for us is to define it in a free body diagram. This is your free body diagram. Again, my objective is really not to teach you how to draw that free body diagram, but my objective is for you to understand that later on in the statics, you're going to learn that very well. I think for those of you who've done physics, you might have already seen it as well. But the idea here is to show the forces so we can describe them in a vector form. Is this TV moving? No. Therefore, it is in a state of equilibrium. What does that mean? That's right. All the forces should sum up to zero. Right? All the forces should sum up to zero. What are the forces in this case? One is, yeah? So basically F, N, and W. Right? F, N, and W. Do we have to worry about their signs? No, because the signs will come when we describe them in a vector format. So basically for us, that's what we get. Right? The summation of all the forces should be zero because this system is in equilibrium. So we need to describe each of them in an IJ coordinate system. Now, I know that you are familiar with I and J to be always in the X and Y direction. X and Y does not always have to be this way. In fact, we can rotate it any way we want because it would only allow us, we need to use a coordinate system that will make this free body diagram as simple as possible. So in this case, this is your x, and this is, so this is called a rotated coordinate system. Makes it much simpler. So in this system, that would be my I, and that would be my j. Okay? So, if I want to describe vector f in this I and j coordinate system, what would f be equal to? Does it have any j component? So it would only be in the I direction. So what I have really is equal to the magnitude of f, whatever that is, times I bar. Do you follow this? This is same as saying fi bar plus 0 j bar, because it is a vector. But because the j portion is 0, that's how I described it. Do you follow that? So what is the next thing? The next thing is to show n. How do we describe n in this case? Yes. Only in j, because it does not have any I component. So in this case, it is going to be n times j bar. Do you see that? So now I have described the friction force, and I have described the normal force. The next thing for me is to describe what? W, right? Does that W have I component? Does it have I component? Yes, right here. Is it negative or positive? Negative, because it's in the negative direction. Does it have j component? Is it negative or positive? Because there you are. Great. So now I have to describe W. Where did 30 come from? Right. You see this? I could have said on the I direction is that 30 degrees, and I'm using the sign because this is the side I'm looking at. Could I have used a cos of 40 degrees? Yes, I mean 60 degrees. Cos of 60 degrees, yeah, because that's the 60 degree right there. So this portion that we have is pointing on the basically reflection of that vector on the x-axis, which is in this case a negative. And they're both negative because they are both in the negative I and j direction. Yes? Where is the 60 degrees? The 60 degree is right here. The angle between that and this angle at the bottom. Right? So to simplify it, this is what we get. So what's the next step we need to do here? Yes? Well, so basically you want to replace all of those vectors in the original equation, which was basically defining the equilibrium. Putting the value of F, N, and W. Do everyone follow? Don't be shy. If you don't understand, just raise your hand. Okay, so I just replaced those in there, in that equation. This is what we get. I, J, I, and J is equal to 0. So what is the next thing? Our objective is to find out what the friction force and the normal force is, right? What is the friction force and what is the normal force? What do I do here? Come on, say it loud. Don't worry. What do we do here? Same as before. We have I terms and the J terms. If you factorize I and J, what we are saying is this is equal to 0I plus 0J. 0I plus 0J. So all we have to do is equate I and J components to 0. Which in this case means the I portion is F minus 490.5 is equal to 0, giving us F minus this, and N minus 849.6 is equal to 0, which gives me the normal force. And those are your final answers. Yes?
Going back up to where the weight vector is underneath here, should the I's and the J's be switched?
Where?
When it says negative 981 sine 39.
Over there? Should it be? Yes or no? Answer him. Come on. Speak up. I agree with him.
My fellow colleague thinks that he's correct.
He's correct? Yeah, go ahead. Why? Because sine of 30 degrees is what? Negative? Is that what you said? See, look at W. W, yes.
Well, I mean, if you look at it like in the quadrant perspective, it's both like not the third quadrant, that's going to be negative. But
Right.
you use sine because like you're coming from the other direction. So if you have like sine is opposite over hypotenuse.
Mm-hmm.
You were using the opposite instead of like what you were using. That's why you said like if you had the 60, it would be cosine.
That's right. That's right. Okay? Did it answer the question? All right. Anyway, so we use a vector analogy to find F and N. Does that physically make sense? Now again, it must physically make sense because the weight of this TV is 981 newtons, right? Therefore, if I came up with N as 1,200 newtons, would that make sense? No. Yes. No. Why? That's right. So you get an answer, you have to, look at it and say, well, does that physically make sense to me? And if it doesn't, then it's inaccurate. I keep going back at it. See, I keep going back to using your logic, your own understanding of the problem. Does that make sense? Is F is equal to 1,000 Newton. because the friction force cannot be more than the weight. In other words, for the friction force to be almost equal to your weight, let's say if the friction force comes up as, I don't know, 979. What that tells you is that the slope that you're dealing with is almost like this. And still the TV is hanging there. You see that? Because when it gets to this point, when the friction force equals, that means it's a vertical and it's going to fall down. There's nothing holding it back. Okay? As we are going from here to there, the friction force increases, doesn't it? Because as you increase the slope, the chances of that TV falling down becomes, that's right. Okay? We're going to do the complex numbers on Wednesday. So no more time today.